I am Likita from B.SC MPC final year in Telangana Tribal Welfare Residential Degree College, Women's Shadnagar. Today I am going to explain about crystal systems and types of lattices. Before going to know crystal systems and types of lattices, I am going to begin with introduction. What is matter? Matter is a substance made up of various types of particles which occupies physical space and has inertia. Inertia means which contains volume and mass. Matter are four types. They are solids, liquids, gases and plasma. As in these four types, the atoms are arranged in different types. As in solids, solids have definite shape and fixed volume. In liquids, there is no definite shape but fixed volume. In gases, there is no definite shape and fixed volume. Plasma have freely charged particles, usually in equal numbers. Now let us discuss about solids. All solids are the properties of rigidity and incompressibility, and the atoms are arranged closely packed materials, atoms in the solids. Solids are classified into two types on the basis of X-ray diffraction. The two types are amorphous solids, crystalline solids. Amorphous solids, when the constant particles are not arranged in regular manner but they are arranged in random manner. Glass, plastic, rubber are some examples of amorphous solids. Amorphous solids do not have flat surface and they are not true solids. As we look at here in the slide, the atoms are arranged in random manner in these amorphous solids. Crystalline solids. Crystalline solids, when the constant particles are arranged in definite geometric pattern, is known as crystalline solids, and they are arranged in an ordered manner. The examples for crystalline solids are raw salt, carbon, metals, and these are all some examples of crystalline solids. Generally, crystalline solids are bounded by flat surfaces and practically they are incompressibility, and we can consider crystal solids as true solids. As we see in the slide, the crystal solids are arranged, the atoms are arranged in random manner and in order. It gives a crystal structure in a definite manner. And now I am going to discuss about subtopics: solid state physics, lattice, unit cell, basis, crystal structure and crystal systems and Brevis lattices. Now let us turn into next point, solid state physics. Solid state physics, study of rigid solid matter. It is defined as the study of macroscopic properties in terms of microscopic properties in solids is known as solid state physics. It is also defined as the branch of physics which deals the physical properties of solids and the atoms are arranged in the solid, especially in crystalline solids. Now let us discuss about lattice. Lattice is defined as array of points in a space, environment identical. Array of points in a space such that environment of each lattice is identical. As we look at here, there are different types of lattices in two-dimensional figure. These are the lattices of two-dimension figure which gives definite shape of real crystal in geometric pattern. As we see here, there are lattice points. The distance between two successive points A in x direction and the distance between two successive points in y direction is B. As we consider any lattice point in this system, the distance between two successive points will in x direction will be as A and in y direction it will be as B. As we see here, this is the oblique in 2-dimension figure which gives lattice points in geometric pattern, and this is the other type of crystal system that is known as hexagonal system, which is showing lattice points in geometric pattern. And the crystal systems are the crystal lattice is not identical, because the choice of crystal lattice or types of translation vectors will be not identical. Now, let us discuss about crystal systems and types of lattices. In this figure, you can see that there are 3 types: simple cubic, body centered cubic and face centered cubic. As we see here in the figure, in simple cubic, the lattice points are occupied at the corners of the only at the corners of the cubic. This is simple cubic. As we see here in body centered cubic system, the atoms or molecules or ions are occupied at the corners of the unit cell and also at the body centered of the body centered unit cell. As we see in face centered unit cell, the atoms are occupied at the corners of the unit cell and at the center of each face of it. For cube, there are 6 phases, and the lattice point or atom occupies at the center of each phase is known as face centered unit cell. Now, as you see this figure, this is the 3-dimensional figure which contains lattice points and grids. As we look at here, this is the crystal structure. These are the grid lines which are intersected with a point lattice. This is known as lattice point and these are the grid lines. Now, let us discuss about unit cell. Unit cell is a smallest geometrical figure, translation repetition of which gives entire crystal structure. As we think, this is the crystal system and this is the unit cell of this crystal, the translation repetition of the unit cell which gives the entire crystal structure, and the unit cell is not unique. As we take this as a unit cell and the translation repetition of this unit cell which does not use the entire crystal structure. This unit cell which it gives the some extra part of this crystal system. So, we can't consider this as a unit cell. As we take the other unit cell, if we arrange the translation repetition figure which gives the entire crystal structure, this can be considered as unit cell, and the choice of unit cell is not unique. Parameters of a unit cell. There are 6 parameters. 3 are edges which are denoted as A, B and C, and the angles between 3 edges are denoted as alpha, beta, gamma. As you can observe in the figure, this is the cube and which has the edges, 3 edges A, B and C. The angle between A and B is gamma and B and C is alpha, C and A is beta. These are the 6 parameters of a unit cell. And types of unit cells. Types of unit cells are 2 types: primitive unit cell and centered unit cell. Primitive unit cell is also known as simple unit cell. As we say simple unit cell, the particles which occupy only at the corners of the unit cell. Think this as a simple cell and the lattice points or atoms are occupied only at the corners of the unit cell is known as simple unit cell or primitive unit cell. There are 8 corners, so the lattice point occupies only at the 8 corners of it. Centered unit cell. Centered unit cell means when the atoms are occupied at the corners of the unit cell as well as in other positions of the unit cell is known as centered unit cell. Centered unit cells are 3 types: body centered unit cell, face centered unit cell and base centered unit cell. Body centered unit cell. The atoms which are occupied at the corners of the unit cell and at the center of the body is known as body centered unit cell. Now, face centered unit cell. Face centered unit cell occupies the lattice points at the corners of the unit cell and as well as at the center of each face. There are 6 faces to this tube and each lattice point occupies at the center of each face is known as face centered unit cell. Base centered unit cell. Base centered unit cell is also known as end centered unit cell. The lattice point occupies at the corners of the unit cell and at the opposite sides of each face, opposite sides of faces. At the center of the opposite faces is known as body centered unit cell. Now, let us discuss about bases. Bases, a group of atoms attached to each lattice point. Here there is a lattice point in this unit cell and the number of group of atoms will be placed at this lattice point. This group is known as bases and the combination of lattice plus bases which gives crystal structure. In crystal structure, both lattice and bases are important. What is structure? Crystal structure means the atoms or ions or molecules which are arranged in an ordered and in a single path is known as crystal structure. Crystal structure are broadly classified into 2 types: polycrystal and single crystal. Polycrystal, the atoms which are arranged in random manner and there will be very small crystallites in this crystal is known as polycrystal. And single crystal. Single crystal means the atoms or molecules or ions which are arranged in ordered way and in regular manner is known as single crystal, and single crystals are also known as in long range term. Now, let us discuss about crystal systems and Brevis lattices. Crystal systems. In 2 dimension, crystal systems are classified into 5 distinct types. The 5 distinct types of lattices are square, rectangular, center rectangular, oblique and hexagonal. These are the 5 distinct types of lattices called Brevis lattices in 2-dimensional crystal systems. Now, in 3 dimension, the crystal systems are classified into 7 types, and in these 7 types of crystal systems, there are 14 types of lattices which are known as Brevis lattices. Brevis is a scientist who showed that only 14 types of lattices are in space such that the environment about each lattice point is identical, and crystal systems are 7 types. The 7 types crystal systems are cubic system, tetragonal system, trigonal system, hexagonal system, monoclinic system, triclinic system and orthorhombic system. These are the 7 types of systems, and the 14 types of lattices are embedded in these 7 types of crystal systems. Now, let us discuss about each system, how they are arranged with the edges and angles between them, and in each system how many types of lattices are there we will discuss. In cubic system, see, as you see in this figure, in cubic system the angles are 90 degrees which are perpendicular, and the three axes are equal, A equal to B equal to C, and they are perpendicular to each other. And in cubic system there are three types of lattices: simple cubic, body centered cubic, and face centered cubic. These are the three types of lattices which are in cubic system. In case of tetragonal system, the two axes are equal in length. As you can see in figure, here the top and bottom of the tetragonal is in square and opposite faces of it is in rectangular. So, the two axes are equal in length and they are perpendicular to each other. See here, if we measure the angle between these three axes, we get 90 degrees. In tetragonal system, there are two types of lattices: simple tetragonal and body centered tetragonal. Now, in case of orthorhombic system, the three axis length is unequal. As you can see in figure, the length of these three axes are different. This is the more length when compared to other two length. So, A not equal to B not equal to C, but the angle between those three axes are 90 degrees. So, we can say it as perpendicular to each other. In case of orthorhombic system, there are four types of lattices: simple orthorhombic, body centered orthorhombic, face centered orthorhombic, and base centered orthorhombic. As we see in rhombohedral system is also known as trigonal system, and in case of rhombohedral system, the three axes are equal in length and the angles between them are also equal, but they are not perpendicular to each other. See, in this figure you can observe that the three edges and three axes are equal in length, but the angles are maybe in 60 degrees or some other degrees, but they are not perpendicular to each other. In case of in rhombohedral system, there are only single type of system, that is simple rhombohedral system. And in case of monoclinic system, the three axes are not equal and the two axes are perpendicular to each other. As you can see in figure, the three length or edges of the axis are unequal in length. A not equal to B not equal to C, and the two here in these two edges the angle is 90 degrees. As we see between these two edges, the angle is not 90 degrees. And in monoclinic system, there are two types of lattices: simple monoclinic and base centered monoclinic. Now, in triclinic system, the three axes are unequal in length and they are not perpendicular to each other. As you can see in figure, the three axes are in different length and they are not in perpendicular. And in triclinic system, there is only one type of lattices, that is simple triclinic system. In hexagonal system, the two axes are equal in length and the horizontal plane which gives the angle 120 degrees. As you can see in this figure, the two axes are equal when compared to the other one, and the horizontal plane which gives 120 degrees of this system. In case of hexagonal system, there is only one type of lattices, that is simple hexagonal system. As we discussed in these, there are three axes and angles between them. What are the three axes? The three axes are denoted as A, B, C, and they are called lattice vectors. And the angles or the axis between any system, the three axes are different in directions of crystal vectors is known as crystal site or lattice axis, and they are also called as basis vectors and translation vectors. Now, and by knowing this, the choice of translation vector is not identical. Now, as we discussed alpha, beta, gamma, and these are the angles between the three axes which gives some are in perpendicular to each other and the some angles are not in perpendicular to each other. Now, I am going to discuss about types of lattices. In types of lattices, there are 4 types: simple unit cell, body centered unit cell, face centered unit cell, and base centered unit cell. Before going to discuss about these 4 types of lattices, I am going to explain about number of lattice points per unit cell and packing efficiency and coordination number. Number of lattice points per unit cell is defined as the atoms or lattice point at the corner of here there is a lattice point which is shared by 8 unit cells, and the contribution of each lattice point for the 8 unit cells is 1/8th part, and 1/8 into 8 which gives 1 lattice, and the number of lattice point per unit cell in simple unit cell is 1. And the coordination number means the center atom which are having nearest neighboring atoms which gives coordination number. And packing efficiency is defined as atomic packing fraction is defined as the volume occupied by all atoms in a unit cell to the total volume occupied by unit cell. Volume occupied by all atoms means the number of the volume occupied by one atom and the number of lattice points per unit cell. And the packing efficiency is also calculated by the volume means which gives 4/3 pi r cube and into number of lattice points per unit cell which is denoted as capital N and divided by A cube means total volume occupied by the unit cell. And in simple unit cell, the number of lattice points per unit cell is 1, and the coordination number means the centered atom contains 6 nearest neighboring atoms. So, the coordination number of simple unit cell is 6, and the packing efficiency of simple unit cell is 52% as the remaining part is vacant. In body centered unit cell, the number of lattice points per unit cell means the lattice point, the one lattice point which is shared by 8 other unit cells which gives 1 lattice point, and the body centered lattice point is 1 lattice point, 1 plus 1 equal which gives 2. So, and the body centered lattice point not shared by other unit cells. Coordination number of body centered unit cell is 8. The centered atom contains 8 nearest neighboring points is, so the coordination number of body centered unit cell is 8. The packing efficiency of body centered unit cell is 68%, means in this crystal system or unit cell the atoms are occupied only 68% and the remaining 32% will be empty. Now, in face centered unit cell, the number of lattice points per unit cell equal to 4, and the lattice point which has which is gives the corners of the lattice point gives one lattice point, and the each face contains one lattice point. So, there are 6 faces, contain each centered lattice point occupies half of it. So, the 6 faces 1 by 2 into 6, which gives 3 lattice points, 1 plus 3 equal to 4 in face centered unit cell, and the coordination number of face centered unit cell is 12. The centered atom contains 12 nearest neighboring atoms. So, the coordination number of face centered unit cell is 12. Packing efficiency of face centered unit cell is 74%. The atoms occupies 74% of the face centered unit cell, and the remaining 26% which is empty. In base centered unit cell, the number of lattice points per unit cell is 2. The lattice point which gives corners as 1, and the face center lattice point gives 1. So, there 1 plus 1 equal to 2. Coordination number of base centered unit cell equal to 4. Packing efficiency of base centered unit cell is 37%, which occupies the unit cell, and the remaining 63% is vacant. And there are some doubts as why crystal system structure is important, or do rocks have crystal structure, what determine the shape of crystals, Shape of crystal is determined by the axis. These are the 3 axes which determine the shape, and the angles between them also determines the shape of the crystal. Do rocks have crystal structure? Rocks also have crystal structure, but there are some conditions. The conditions are which contain temperature and pressure, and the chemical formula will be same, but the crystal shape will be different. That is called polymorphs. Why crystal structure is important? As we see in graphite and diamond, there are only carbon atoms, but the carbon atoms are arranged in different types. So, the crystal structure is important. Now, I am going to conclude that in crystal systems we learnt about solid state physics, lattice, basis, unit cell, crystal structure, crystal systems, and Brevis lattices and types of lattices. Now, I am going to thankful to the Gurukulam and TSAT and all my supporters and the listeners for all. Thank you.